Welcome back to the deep dive. If you've ever looked at a cloud bill or tried to deploy a modern application, you know the absolute core of the discussion. It eventually comes down to one question.
Where do I put the data?
Exactly. Where do we put the data?
And we're not talking about just, saving a document. We're talking about fundamental architectural choices that define your entire application stack. So today, we are diving deep into the big three of AWS storage.
S3, EBS, and EFS.
That's them.
And this isn't just about, memorizing acronyms for a cert exam. Our mission here is to really synthesize these three, because the choice you make, it fundamentally dictates three things for you.
Right. How fast your application runs.
How much your disaster recovery is going to cost you.
And maybe most importantly, whether you're paying for capacity you aren't even using.
We need to get the function before we look at the features. So we're tackling S3, the simple storage service.
EBS, the Elastic Block Store.
And EFS, the Elastic File System.
And let's start with the one that, well, it started it all. The foundational service that really underpins most of the internet today. S3.
Okay, so S3, whenever I try to explain it, object storage, I tell people to forget everything they know about a normal computer. It is not a hard drive. It's more like a massive, infinite valet parking lot.
That is the perfect way to think about it. It's a total mental shift. When you upload data to S3, you're not saving a file to a folder. You're creating an object, and you place that object inside what's called a bucket.
The whole operating system layer is just gone.
Gone. Each object just gets a key, its unique ID, and the data itself, and that's it.
That structural simplicity is what's so revolutionary. So if you don't have to worry about a traditional file system, what does that unlock? I mean, in terms of scale.
It unlocks the key word for S3, infinite. And we mean, virtually unlimited scale. You could store a petabyte, an exabyte.
The entire written history of humankind.
And S3 would handle it. The scalability is, it's just truly mind-boggling.
And because it was built from day one to be web-enabled, every single one of those objects can get its own URL.
Which is why S3 is the workhorse for everything from, static website hosting to distributing massive video files for streaming services.
Okay, let's talk durability, because this is where S3 has this legendary status.
It really does. We're talking about the famous 11 nines of durability, 99.99999999999%.
Which in practical terms just means it's not getting lost.
Pretty much. AWS automatically replicates your data across multiple physical data centers, the availability zones, within a region. So if a meteor hits one building, the other 2 or 3 still have your data safe and sound.
That sounds supremely safe. But here's the insight we need to pull out for you. Cost isn't just about how much you store, it's about the access pattern. So if S3 is so cheap to store data, what's the hidden cost?
The hidden cost is retrieval, or more accurately, the cost of egress, getting your data out. Storing it is cheap, especially if you use the different storage tiers like infrequent access or Glacier for deep archive. But you pay every time you pull that data out of AWS and send it over the public internet.
So S3 is a cheap hotel, but the room service bill at the end is what gets you.
That's a great analogy. And the cost structure is designed to reward you for planning. If you have logs you'll only touch once a year, you push them to Glacier Deep Archive. The storage cost is almost nothing.
But if you need them tomorrow,
you're paying a much higher retrieval fee, and you're going to wait longer for it too. It's all about matching the access tier to your actual need.
Okay, so we've got S3. It's the infinitely scalable, durable, web-accessible warehouse. But there's a huge limitation. You can't run a database or an operating system directly on S3.
No, you can't. The object model just can't handle the constant low-latency read-write requests that a server's root volume needs. And that limitation forces us to pivot pretty sharply over to EBS.
The Elastic Block Store. So if S3 is the distant warehouse, EBS is the hard drive sitting right inside your server. We're talking about block storage now.
Right. Block storage provides raw, unformatted blocks of data to the operating system. It mimics a physical drive, your C drive, your root volume. Yeah. It's absolutely necessary for running an EC2 instance because the OS itself needs to manage the file system.
And the critical rule here, the one you absolutely must remember, is the exclusivity. You provision an EBS volume, say 500 gigs, and you attach it to generally one single EC2 instance.
It's a one-to-one relationship.
A one-to-one attachment, and that exclusivity is the magic sauce for performance.
It is. Because it's mimicking that direct connection, the latency is incredibly low, milliseconds. This is why EBS is the undisputed king for any kind of transactional workload like a database. They demand high input-output operations per second. IOPS.
IPS is a huge concept here. And you mentioned S3 is pay for what you use,
Mhm.
but with EBS, that model flips completely.
It does. With EBS, you pay for what you
So
provision.
you pay for the guarantee.
Yes. You pay for the guaranteed capacity and the guaranteed performance, whether you use it or not. If you provision a 500 GD volume for the IOPS, you pay for all 500 gigs, even if you only write 1 kilobyte to it.
You're paying for the potential. And architects often get tripped up on the different volume types. Can you break down just briefly the difference between a general purpose one like a GP3 and, I don't know, an IO2?
Sure. The general purpose ones, the GP3s, are really cost effective. They give you a solid baseline of performance, perfect for most web servers. But if you have, say, a mission-critical financial database, you move to the provisioned IOPS volumes, like IO2.
Or you literally dial it in.
You literally tell AWS, I need this volume to sustain 50,000 IOPS, and you pay extra for that guarantee. You're trading cost for guaranteed, rock-solid, low-latency performance.
Okay, so speed, guaranteed IOPS. But here is the massive catch. The availability zone lock. That sounds terrifying. Is the speed really worth that limitation?
Well, it's the inherent trade-off. An EBS volume is tied to a single physical availability zone. If your server is an AZA, the EBS volume must also be an AZA. It's a digital leash.
So if AZA goes down,
You can't just detach that drive and reattach it to a server running an AZB. It doesn't work that way.
so survival requires you to constantly be taking snapshots.
Precisely. You have to take snapshots of the volume, which, by the way, gets stored in S3 for durability, and then you have to recreate the volume from that snapshot in a different AZ to attach it to a new server. It's a recovery process, not automatic resilience.
Okay, so let's recap. S3, infinite multi-AZ but can't run an OS. EBS, lightning fast, single server but locked to one AZ. What if I need my servers to share files? What if 10 web servers need to read the exact same image right now?
EBS can't do it, and that's the perfect transition. We need a system that gives us that file system feel, but with the flexibility to be attached to many hosts at once. And that brings us to EFS, the Elastic File System.
The shared folder, this is the network drive you had at the office, right? Using the old NFS protocol.
The Network File System Protocol, yes. Its entire value proposition is sharing data across servers. Dozens, hundreds of EC2 instances can all read and write to the same EFS location at the same time. It's essential for things like content management systems or big data jobs where a bunch of computers need to crunch the same data set.
So that sounds like it solves the two biggest headaches of EBS right away.
It does. It solves the single instance problem and the availability zone lock.
How so?
EFS is inherently regional. Just like S3, its data lives across multiple AZs right out of the box. So if your server fleet is spread out and one zone goes offline, the other servers just keep working. The resilience is baked in.
And the elastic part of the name
Yes.
that suggests we're not provisioning space anymore, no more paying for that 500 GREs we aren't using.
That's right. EFS is truly consumption-based. You don't guess a size. You just start using it. You put 100 GB of data on it. You pay for 100 GB. You delete half of it. It shrinks, and you only pay for the remaining 50 GB. It's incredibly convenient.
Okay, convenience and resilience are great, but there's always a price. I've always heard that EFS is generally the most expensive of the three per gigabyte. Why is that?
Because you're paying for all that magic.
Yeah.
The automatic, simultaneous, multi-AZ replication, plus the overhead of the network protocol. You are asking for the best of both worlds, shared access and resilience, and that just costs more.
And there must be a performance trade-off, too.
Oh, absolutely. Because it's using NFS over the network, it will never, ever be as low latency as a direct attached EBS volume. That's the primary trade-off you accept for the ability to share.
That makes perfect sense. Okay, let's lock this in. S3 is the warehouse, EBS is the fast exclusive hard drive, and EFS is the shared network folder. Let's run some rapid-fire scenarios.
Let's do it.
Scenario 1. You're building a high-frequency trading platform. You need a dedicated spot for your PostgreSQL database. Millions of transactions. Speed is everything.
EBS, specifically a high IOPS provision volume like an IO2, no question. Databases need that raw block-level speed.
Okay. Scenario 2. Your app generates terabytes of analytical data. Sensor readings, user logs. You have to keep it for 7 years for compliance, but you almost never look at it.
S3, 100%. And not just S3 standard. You'd use a lifecycle policy to push it straight into S3 Glacier or even Glacier Deep Archive. It's all about massive scale, minimal cost.
Scenario 3. You're deploying a highly available e-commerce site. 3 availability zones. All 6 of your web servers need to read and write product images from one central place.
EFS, hands down. You need simultaneous multi-instance access across ASes. EFS is literally built for this exact problem.
Perfect. Last one, scenario 4. You have a simple marketing website, just HTML, CSS, images. You want it up 247 without ever having to manage a single server.
S3. Classic static website hosting. You use the durability and web-native features of object storage, and since there's no EC2 involved, your maintenance cost is practically zero.
That really drives it home. The access pattern and the scale requirement
Yeah.
that defines the right choice every single time.
It really is never one size fits all. So let's leave you with the distilled one-liners, the shortcut.
Go for it.
S3. Internet accessible object storage. Think infinite scale. But remember those egress costs.
Okay, EDS.
EBS. Single instance accessible block storage. Think lightning fast, fixed capacity. But remember that AZ lock.
And finally, EFS.
EFS. Shared accessible. File storage. Think elastic and regional. But remember that latency trade-off.
Understanding those trade-offs, access versus speed, scale versus cost. That's what makes you an effective cloud architect. You now have the 3 pillars of AWS storage clear.
And so here's the final thought we want you to mull over. If you know that connecting one EC2 instance to one EBS volume gives you that super low latency raw block access, and EFS gives you the convenience of sharing data across dozens of instances, where does that latency hit EFS the hardest? Think about the implications of those protocol differences, block versus file, when you're designing the next generation of, say, highly concurrent AI or machine learning workloads.